Hello, everybody. I'm glad to see you on our stream. It's stream of Codeberry Club community. Today we are going to talk about performance. We had a stream about performance before, and Vadzim was a speaker last time. Today we will continue, and Vadim will tell us about Spring Reactive performance and compare it with native Java performance. Feel free to follow us on YouTube. Feel free to write comments, like or dislike our video. And Vadim, hello.
Hi everyone. Today I'm going to provide you some information regarding the performance of Spring Reactive and Spring Reactive as native, and we'll compare them with the previous one researches that I provided you before on the Spring Web Stack and Spring Web on native manner. And what we are going to have today, I'll share with you my agenda. First of all, I'll introduce myself. I'll tell you where I am and you're going to listen me. Probably I can bring something new into your knowledge and bridge some gaps. Then I'll provide some brief introduction regarding what is exactly reactive on the high level. Reactive manifesto compare Spring Reactive and Spring Web, and one more time, I'll describe the business idea of the application that we are going to stress test. And after that, we'll take a look on the results of the tests of the pre-reactive and pre-reactive as native and compare with the web results. And we'll sum up and gather all the information. So let's move on to the next slide, and I'll tell you about my experience, domains, technical stack, and social networks. I'll share them with you as well. So my name is Vadzim Kavalkou, as I mentioned before, and I'm a chief software engineer with more than 7 years of IT experience, and my key business domains are finances, human resources, crowdfunding, and healthcare. I'm a T-shaped person, and mostly I'm working in the JVM stack area and have a proven practical experience with Java, Kotlin, Spring, Spring Native, Reactive, JIB, Docker, OpenAPI, Gradle, etc. For sure, as I mentioned, I'm T-shaped, and I'm familiar with the Kubernetes and GitHub, GitLab CI, JMeter, and Kotlin performance testing, Google Cloud Development, and Architecture. Here you can find my social networks such as LinkedIn and GitHub and Instagram. On my GitHub, you can find the whole description of this presentation, but I'll share a QR code in the end of the presentation. Okay, so the introduction. On the introduction, we'll describe on the high level what is the Reactive Manifestos, what is a reactive Spring, and compare it with Spring Web, and we'll talk a bit about the Spring R2DBC. What is the Reactive Manifesto? Reactive Manifesto consists of 4 pillars. They are responsive, resilient, message-driven, and elastic. So what is the responsive? Responsive, it's a deliver a consistent quality of service to end users or system, react quickly and consistently to events happening in the system. So what is a resilient? Resilient, it's a stay responsive in the face of failure. This is a key characteristic. It applies distributed systems. Message-driven is about the underlying behaviors to have an asynchronous message-driven backbone to enable loose coupling of the application components by exchanging asynchronous messages to minimize or isolate negative effects or for resource contention, coherency, delays, and inter-service communication network latency. It is based to support their other reactive characteristics. It also helps for isolation and support application transparency. The elastic. Elastic is is about the system stays responsive under varying workload. It can scale up or scale down the resource utilization depending on the load to the system. Okay, what is Spring Reactive and what is reactive processing? Reactive processing is a paradigm that enables developers to build non-blocking asynchronous applications that can handle back pressure. There are different ways of developing back pressure. It could be just a queuing or skipping the request, or the most correct in my mind is talking with the client that hey, stop, I'm not able to handle much more requests. You can take a look on their R socket, for example, listen Oleg Dakuka presentations. There are a lot of his speeches on the YouTube where he described it more in details. So the whole purpose of reactive streams was to introduce a standard for synchronous stream processing of data with non-blocking back pressure. Hence, Java 9 introduced the reactive streams API. It's implemented based upon the publish-subscribe model or producer-consumer model, and primarily defines four interfaces. One of them a publisher, second is subscriber, and third subscription, and fourth a processor. Let's compare Spring Reactive and Spring Web. So reactive stack is Spring Web Flex. Is a non-blocking web framework built from the ground up to take advantage of multi-core next-generation processor and handle massive numbers of concurrent connection. It based on the NetT or servlet C plus C.1 plus containers. It had reactive streams adapters, and moreover, it supports Spring Data reactive repositories for MongoDB and Redis Couchbase or R2DBC. But Spring Web is built on the Servlet API and uses a synchronous blocking I/O architecture with a one request per thread model, and based on the Servlet containers, Servlet API, and supports Spring Data repositories such as JDBC, JPA, and NoSQL. What is a Spring R2DBC? Spring R2DBC based on the reactive Spring specification. R2DBC is founded on the reactive Spring specification, which provides a fully reactive non-blocking API. Works with relational databases. In contrast to the blocking nature of JDBC, R2DBC allows you to work with SQL databases using reactive API. It supports scalable solutions. With reactive stream, R2DBC enables you to move from the classic one thread per connection model to a more powerful and scalable approach. Provides an open specification. R2DBC is an open specification and established a service provider interface (SPI) for driver vendors to implement and clients to consume. So R2DBC stands for Reactive Relational Database Connectivity, a specification to integrate SQL databases using reactive drivers. Spring Data R2DBC applies familiar Spring abstractions and repositories support for R2DBC. It makes it easier to build Spring Power applications that use relational data access technologies in a reactive application stack. R2DBC is about the simplifying, and to achieve it, it doesn't operate caching, lazy loading right behind, or many other features of ORM frameworks. This makes Spring Data R2DBC simple, limited, and opinionated object mapper. I'll share with you my business idea of the application and use cases and database structure. I've shared it before, but I think that we have new viewers, new attendees, and it could be useful for them. So the application logic, what about the application? It's about the transportation service, and we will suggest that it's working from the 8 a.m. till the 12, and it's about the 60 hours per day or 112 hours of load per week. And what about the presets? I disabled all application level sketches to get clear performance metrics of the server as it is. And the database and application are running in the same network to avoid net lags and penalties. And the fetching strategy is eager. It's first of all to have a higher load and non-optimized queries to the database, and second, to not to spend time to stop entity graphs. The average time to boot up the services will not depend on the database structure due to the fact that I've already prepared data sets, and we have no need to use the database migration tools such as Flywheel, like Liquidbase. As I said, I prepared the database structure and I pre-filled it with the fake data. For loading testing tool, I choose Kotlin. I have samples in GitHub. You can find the way of setting up it on your project and bring this experience for you and for your mates. The version of all languages, frameworks, and libraries and databases, the latest LCS at the moment of testing. You will find that I'm using in this testing Spring Boot 2.7.4. But at the moment, we can find that the Spring Boot version, the latest one, is at 2.7.5. Now let's imagine the number of units in use. I decided to launch the application for one country with 6 cities. I love my country. It's about Belarus. So in every city, we have 20 points to be able to arrive or depart. I assume that every point has about 100 transfers, and the target audience is about 200,000 users. And every one of them has at least 2 transfers. So what are base use case scenarios? First of all, as a user, I like to choose the country, choose the city, and choose the origin. And for sure, I'd like to choose a destination. It would be nice to have a point to choose the date of transfer and to find the available transfers from origin to destination for selected date. And as a user, I'd like to book a transfer that I've found on the previous step. And as a user, I'd like to see all my transfers. For sure, I'd like to see all transfers I've booked. I'd like to edit my own transfers in future or cancel them. For sure, I would like to complete any own transfer in past and to see my profile or update it. And this is the base scenarios. We can find assumed operations. Most of them are get, but we can find that we have a put and post operations. And I've presetted it in Kotlin. It was pretty easy. Kotlin provides us good flexibility, and it's pretty agile to set up any performance tests. What about the database structure? Database structure, as I mentioned, we're talking about the Belarus, and it is still the single country. And in this country, you can find 6 major cities. And we will take a look on 120 locations and 12,000 transfers, 200,000 users, and for about 500,000 users transfers. This is what about the predefined data. The relation database is Postgres, and we can find the database structure here, and database size pretty not so big, for about 153 megabytes. Okay, let's move on to the Spring Reactive. We'll take a look on the test results and analyze the Docker image. What about the basic configuration? All the tests I've done on my, I've completed and I've done on my laptop, and all the metrics you can find here. And GTK 17. Garbage collector is the J1's, Gradle version is 7.5.1, and Spring Boot, as I mentioned before, 274. Default setup you can find on this screen that I've enabled compression, and I've predefined that we are using R2DBC, and you can find this on the R2DBC prefix on the URL, and that's it. What about the test results? First of all, I'd like to mention that we proceed for about 1 to 100,000 of requests for about 50 or 70 minutes. It's stress tested, and for these metrics, we have no any caches, as I mentioned before, and it's pretty hard to load the system as I did. We can take a look on the 97th percentile of the response time. For most of our systems, it's pretty high, for about 10 seconds. It's annoying, and I believe any user, to be honest, I'll skip this application, will not use it, but we are testing it to do and to improve the performance in future. So what about the RPS? It's about 1100 count, and the key hours are 8%. The key hours of the list of available transfers for selected origin and data is pretty okay. This means that we just not found the information, we just not found the transfer for preselected data and origin destination. But we can find that we have for about 28% of the KOs on the list of available cities. And this is the reason, this is the point where we've reached our saturation point. We will take a look on it a bit later. So what about the test results? We will compare here our jar and Docker solutions. So our build time for our building our jar is for about 3 seconds. Jar and Docker is 39 seconds, and we have built it with the JIB without any Docker, the Dockerless solution to build the Docker images. And as a based image, I have chosen distroless. It's pretty safety and has a lot of other benefits. You can take a look. What is it after the presentation? And artifact size jar is for about 40 megabytes and 270 megabytes of a Docker image, and boot up to 0.5 for jar and for about 4 seconds for a jar in Docker. Active users are pretty similar, a little bit more than 10,000 users, and RPS for the jar is a bit more than 1,000, and for about 600 RPS for the jar in Docker. And I found the way, and I understand why we have this difference, such a big difference to my mind. And I'll share it with you on the next week, on the next speech regarding the Quarkus. I'll describe you how to avoid these leaks on your, for instance, CI/CD, but not today. So I'll be happy to see you soon. What about the response time? It correlates, if you can find, with the previous metrics and with the saturation points as well. Saturation point for jar is 4,000 and for about 400. And for jar and Docker is a bit more than 2,000. But we can take a look on the memory consumption. JVM heap for jar in average is for about 1,700 megabytes. It's a huge demand and memory consumption. Just to compare it with the jar and Docker, it's for about 8 megabytes. And pretty similar JVM non-heap and threads, but JVM CPU consumption of jar a bit less. And in jar and Docker, we can find a way that Postgres CPU consumption for about 37% and 19% in Java. And if we will take a look on the graph, at the graph response time range, we can find that for about 400,000 of requests can be handled with less than a second, but for about 600,000 can be handled pretty more than 1 second. Okay, as I've mentioned, we've handled for about 1 million requests for 80 minutes. What about the dive in the Docker image? When we are diving the Docker image, we can find that Jeep and Dockerless provides us a potential image efficiency score for 100% and total image of 271 megabyte. I'll compare it in the next presentation on the next week with the Quarkus sizes and Quarkus performance. It could be interesting one because if I've chosen to be on Quarkus different solutions such as UBI or Dockerless as well, but on Quarkus it's an experimental one. So I'll talk about it on next week. What about the Spring Reactive as native? And Spring Reactive as native same solution, but we are building native images or Docker images with a native in it to run it. And at the moment of testing, I've chosen Spring Boot 2.7.4 and Spring AOT is 12.01 version. And I believe that soon we will find a way, a Spring major version, Spring Boot of 3. And in it, with this release, we can see on the Spring IoT major version 1 because there is a version 0. It's an experimental one feature. I'm waiting with the kind of I'm waiting a huge potential of the new major release of Spring Boot, and I believe the Spring team will do it as soon as possible. Okay, pretty simple application YAML, and with R2DBC URL I've provided here, and web application type reactive. It's just for you just to take a look at that. Yeah, we are here working with the reactive one, and when you are trying to build a native image, you can find a lot of pitfalls we can face with them. And when you're using programmatic APIs like REST template or web client, reflection-based serialization like JSON requires additional type hints. And if you take a look at my sources, you can find that I'm using step hints to build correctly my native image. And Kotlin coroutines are supported, but currently require additional reflection entries due to how coroutines generate bytecode with an object return type, and sealed classes are not supported. Custom repositories implementation fragments need to be annotated with a component, and doesn't support Hibernate types, but you can find a way of kind of workarounds, and some starters require special bit configurations. What of the starters you can find on this using this link. And what about the test results? Test results of native solution we've handled for about 1 million requests, and we can find already that we have a high KOR here had been an 8%, and for about 20%, 28% of the list of available cities countries. And in total, we had in previous tab for about 1,200,000 of requests. and the RPS was for about 1,100, and here we can find 900 of requests per seconds, and response time for 95% is for about 20 seconds. And on the previous step, we had 10 seconds as well. Okay, let's compare the solutions that are provided by Spring. We can build a native image using a build pack or native build tools. So first of all, I would like to mention the difference, huge difference in build time. When you're using a build pack, you can spend for about 1,000 seconds, and for native build tools for about 200 seconds. And and artifact size for about 100 using the build pack, and native build tools for about 70 megabytes. Boot up type are pretty similar. It's about 100 milliseconds. And just to compare it with the previous one, solution where we had for about 3 seconds of boot up time, it's pretty good numbers. The similar active users and RPS for a build pack are pretty similar for the Docker Java in Docker solution of using non-native solution, and native build tools, as I mentioned before, 900. Response time a bit higher, and saturation point a bit less. RAM consumption in this way, we can find that we are not facing with the 1,700 of megabyte of RAM consumption. On the native build tools, it's a bit more of 600 megabytes. CPU consumption pretty similar of these two types, build pack and native build tools, about 30%, and threads and build pack for about 40, and native build tools 23, and Postgres CPU consumption is for about 60 or 70%. And but we, as you remember, I believe you remember, we can find that most of the requests can be handled with more than 1 second, and we can find the same results here. But for requests that can be held less than a second, on previous solution we had a bit more than 400,000. Oops, am I here? Sorry.
Yes, you're here.
Oh, and just seems that my desktop is. I'm not able to switch my presentation. Sorry for interrupting. And we were so close to compare the solution with the Spring Web and the Spring Reactive, but now
We're sorry, there is some technical problems. Please wait for 1-2 minutes. We will return. Thank you.
Okay, I'm back.
Yes, you're here. Please continue.
Yeah, yep. I'll present my screen and continue. Sorry for interrupting the presentation. Sounds in my bad. Okay, and sure. Could you please tell me, are you able to see my screen?
Yes, but
And
there is
my presentation.
no, there is a StreamYard screen. Please.
Okay. Oh.
Presentation.
And now?
Yeah, everything is right.
Awesome. Sorry one more time. And could you please remind me where you lost me? I've been speaking about the results of native build tools and build pack and the results of the RPS of
Yeah,
the request that have been less than 1 second.
CPY, our participants RAM.
Sorry, could you please repeat?
Yes, our participants said that you stopped at CPU and RAM.
RAM, CPU RAM. Okay, sorry. So I'll continue. And I'd like to mention and remind you that on the previous tests of a non-native solution, we've had a bit pretty more numbers of requests that can be handled less than a second. We can take a look at right here and find it right here. This is not native solution. But right now we have, not such a great picture. Okay, so Docker image analysis. So we can take a look at it and find that image efficiency score is 99%, and when we use JIB and Dockerless, we reach 100 efficiency score. I didn't think that's a big deal, but it could be improved. 1% is a 1%. So web versus reactive. We'll compare jar test results and compare native test results, compare all of them. And on the previous research for Spring Wrap, we had a build time a bit higher for about 5 seconds. Right now we have it for about 3 seconds using Spring Reactive, and artifact size a bit less of Spring Reactive. It's for about 40 megabytes, and it was about 50 megabytes for Spring Web. And what about the boot up? Boot up a bit less, about 2 seconds, and for about 3 seconds for Spring Web. And but memory consumption for Spring Reactive, we find a way that we've used for about 1,700 megabytes, and now on the Spring Web solution we have about 600. A bit less CPU consumption for Spring Reactive solution. And comparing the RPS, for sure, this is not non-blocking asynchronous communication style, and we can find that using the Spring Web solution, we didn't reach even 400 RPS, and using Spring Reactive, we have hit more than 1,000 RPS, and the saturation point a bit more of 4,000, and it was less than 2,000 for Spring Web. Okay, let's compare native test results. Build time for Spring Web for about 200 seconds and for 210 seconds, and for Spring Reactive, we can find this is less than 200 seconds. And artifact size for Spring Reactive a bit less in compare a bit for about 2 times a bit. For a Spring Reactive as in comparing with the Spring Web. And what about the boot up? Boot up for about 100 of milliseconds. So for Spring Reactive, and 300 milliseconds for Spring Web. And but we can find the RAM consumption for Spring Web for about 200 or 300 megabytes. And right now we reach out that we can find 600 megabytes. And the CPU consumption is pretty high for Spring Reactive in average for in comparison with the Spring Web. Okay, what about the RPS? As we compared it before, for a non-native solution, we've reached high numbers in RPS for about 900 of RPS in comparison with the Spring Web for about 400 RPS. And the saturation point is for about 3000 against the a bit less than 2000 in Spring Web. Okay, let's sum up it and gather everything together. And the 2 points for not choosing the reactive jar solution are if you would like to have a better boot up time, please consider to choose a native compilation. For sure, you solve numbers, it's for about 100 milliseconds. What could be less than it? Use a Spring for sure. And if you would like to have less resource consumption, please take a look at native build tools for web. We can compare it with default reactive applications that consume for about 1,700 megabytes, and native build tools consume for about 600 megabytes. So consumed. And in case you are going to have both of these properties at top, though we are talking about the boot up and less consumption, you could choose this reactive native build tools approach. Okay, what are the pros of using the reactive approach instead of the web one? Less artifact size, on average better boot up time, handling 2.23 times more requests. RPS is better, 2.43 times, and response time is less in 2.8 times. Saturation point is higher in 2.3 times. So if these numbers, you are going to reach these numbers, you could consider to switch to the reactive paradigm and use it and bring it into your application. And that's it. So what about the cons? If you choose the reactive jar approach, you can have RAM consumption increasing 3 times. And in other cases, it's pretty similar and even sometimes better. So it's up to you what to choose for your business needs. You know your business better, and in some cases, you know it better than your customer. You could suggest him what to do and what to bring to production to increase the revenue, etc., etc. So just research your applications and bring modern solutions into your product. And that's it. Using this QR code, you can find the whole investigation and for whole research on the GitHub profile. For sure, you can find the sources. They provided as a link on this research on my GitHub profile. You can subscribe me on the LinkedIn and follow on GitHub or Instagram. Okay, so thank you. Probably you have questions and I can answer you.
Thank you very much for your topic. We have one question One
Mhm.
second, please. It's a very common question. What a chef software engineer does? What is his role about?
Oh, it depends on situation. You could bring some solution review, optimization, modelization, solution architecting, or team leading, or technical leading, contribution on different levels, and bringing newest and modern solutions and to the project. To my mind, this is about it.
Okay, thanks a lot. There is one more question.
Yeah.
What is the reason for the 2-3 times higher RAM consumption?
Oh, I've tried to find a way over it, and I've mentioned before. You can take a look on the Allegra Kuka researches, and the reason of it. I, to be honest, I've a bit forget about it. But if you want, I could provide in comments the link to the Allegra Kuka review of the situation. It was pretty similar one. To be honest, I didn't investigate it. I didn't spend time for it due to the fact that I've compared the performance, not tuning it, uh, and just to bring uh, as soon as possible the most and best fitted solution for your business needs. You are not going to find the way why your performance has a degradation. You are going to bring a quick and reliable, high available, and fault tolerant system for your business needs. This is that's it. To my mind, you should to be honest and just take it simple.
Okay, thank you very much for your answer. We haven't got any questions yet, but I think that we can wait for a minute. Maybe
Okay.
somebody will write something to us. And if not, we will finish our stream.
I'll remind one more time that you can find the sources of research and the sources of the implementation via this QR code. And follow me on the social networks. And thank you everyone who attended this session.
Okay, so we haven't got any questions. So
Okay.
I think that we can finish. Thank you all for participating and for your questions. Thank you, Vadzim, for a really useful topic, and recording of this meeting will be available on our YouTube channel. So please share your feedback about the event, vote for the topic on the event page, and issue a badge to our speaker using the Say Thank You button. The link will appear in the chat soon.
Great.
Thank you.
Thank you. Bye. Liz, could you stop sharing?
Yeah.
Thank you, Vadim, for